Hey man, Networking 101, most fun you can have without spending your money on textbooks. You know, there's two technologies in networking that we would really consider weed out technologies, right? Stuff to make sure that you really want to be a networker. There are subnetting IPv4 and OSI model, right? We all have to learn it. We all have to kind of pay our dues there. And if you make it through there without any brain melting and kind of get it and stuff, well, then maybe a career in networking is just for you. So let's really dig into what this 7-layer model actually is and how it even maps to the what we call the internet model, the TCP/IP model, and how you can use it to troubleshoot your network. It's really more, in my opinion, this stuff is pretty darn valuable stuff. I mean, we teach it up front, and I say weed out kind of as a joke, but sometimes it kind of is. You know, the truth is that this is, if you understand how we containerize all this stuff, it can really help you in troubleshooting your network. So let's go ahead and click on over here. And everybody who's learned networking always remembers the OSI model mnemonic, right? All people seem to need data processing, right? That explains our application, presentation, session, transport, networking, data link, and physical layer. And that's how we actually describe all this stuff. Now, the OSI model was actually wrote by a group called, of course, oops, I'm kind of writing off frame here. The OSI model was actually wrote from a group called the ISO, the International Standards Organization. Man, those folks write all kinds of stuff. So, and what we do here when we're looking at this, this is a very rigid, this is a very hard set way of doing stuff. There is no flexibility in how you actually work this stuff. The OSI model is very, very tightly defined and very, very strict, if you will. And you can really work this in a way. You can go from, you know, from bottom up, or you can go from top down on your processing points. And really, you can kind of enter anywhere you want in here. You don't have to go sequentially through this. You can enter in whatever level that you need to enter. So one that you may be familiar with, like the magic packet, right? You know, magic packet is what will wake up a LAN or wake up a device on LAN, wake on LAN, right? You can send that across. I don't need to go all the way to the application layer to do that. I just need to send the frame tell to, you know, dude, get up. I need to send you an update. So you can really go in and out. Now, these layers also have a very defined methodology of communicating up and down this stack. If it's a protocol, we're going to use what's called a PDU, right? A protocol data unit. If it's going to be a service, we're going to use an SDU, or service data unit. Now, that's a little advanced knowledge, if you will, because chances are you won't be messing with any of that stuff. You know, what you'll be doing, I just really want you to know it exists. Typically you won't mess with that unless you're going to do a lot of programming, you get into writing a lot of code, then you'll be kind of messing around with your PDUs and your SDUs. I want you to know that there's nothing magic that happens to get from what, because these are very well defined, like I said. And so how do we climb the ladder here? Well, we climb the ladder, those rungs are climbed or bridged with PDUs and SDUs. It just kind of helps you understand a little bit. Now, if the OSI model is a very strict uncle, you know, a very disciplinarian guy, then the TCP/IP model is a totally Southern California model, right? Very laid back, very groovy, whatever, man. You know, it's only got 4 layers because, man, it surfs up, man. Don't be bothered with everything else, right? This is what we call TCP/IP model, or some people even call this the internet model. That's really incorrect, but some people call it that. The reality of it is the TCP/IP model. And what you're looking at is what we call an application, transport, internet, and network layers of this device. Very, very loosely defined. So let me show you how this works. They work really together. A lot of times when you're learning this stuff, you learn OSI model and that's it. And then about a couple weeks later, then you'll learn TCP/IP model. My opinion is it should never be taught like that. They need to be taught together because they work together. And the truth is, OSI model is good to know if you're troubleshooting your network, right? Because everything is very containerized. Programmers, code jockeys, we work off of the OSI model. That's how we design stuff. The network reality engineers, we work off the TCP/IP model because that's kind of how the traffic flows. So let's go ahead and take a look at how we map this out. All people seem to need are application, presentation, and session layers. Apps simply maps to apps. Our application layer on our TCP/IP model, that's how these kind of tie out. So that makes that pretty darn easy to remember, right? Now if we look at our next one, our transport layer, that one's pretty darn easy. That one maps simply to the transport layer. Why? Because transport is the same. When we transport this stuff, we've got that well defined, and that is really how we tie all this stuff in. Where it really gets confusing in understanding this stuff is this next one right here, the internet model. The internet side of TCP/IP, I'll draw a dividing line in between that. That will map to the networking, and this is the confusing part, the data link layer model. Now, some people will say, "Oh, Jimmy Ray, you know, that's not true." It doesn't ever. It really depends upon your frame of reference, and it depends upon the documentation you read. I'm telling you that from today's experience, when you look at virtualization and stuff, you're going to see this map to both sides of the house. You're going to see networking and data link layer tied in to this internet side of the house when it comes to the TCP/IP model. And then our final layer, what we call our bits layer, our physical layer, or our networking layer down here, this is what's going to map directly back and forth, because these are just the bits. These are our controls, our voltage levels, that type of stuff. And that's how these really tie all together in your network when you're actually looking at how it troubleshoots. You're going to see this so much more and use this a lot more if you are just a standard networker that messes around with apps, troubleshooting, that kind of thing. If you're a code jockey or a hacker, you're going to be messing around with this a whole lot more, because this is very well defined. And we're going to be looking for, let's say, exploits in like maybe port 80. Oops, let me write that on screen. Let me go to a different slide. So if I'm looking for an exploit in port 80, what am I going to use? I'm going to use the OSI model. Why? Because it's very well defined. Any exploits are going to be in there. Port 25, I'm going to look at that type of stuff, right? If I'm going to write an application, I'm going to look at how, you know, the transport layer interoperates with each other and how I'm going to troubleshoot that stuff. Most of the time, I'm using the TCP/IP model and trying to figure this stuff out. And that's how these work or encapsulate kind of back and forth. Keep it straight. Understand they're both tools for you to understand. They're reference models, right? The only one that's really, really rigid is the OSI, and you don't have to climb all that. That's the biggest mistake. People think you got to start from the bottom and go to the top, or from the top all the way down. Not the case at all. You can enter anywhere you want. Each of these are independent layers of each other, and if they need to communicate, just like you would on a VLAN, you have some type of bridging protocol, and that's how those actually talk back and forth. TCP/IP model laid back, dude, yeah, come on over, man, it's all good. We'll communicate. That's how it all works, man.